2.1.0 Rulers and other measuring tools. I know this is rules. They call them rules, like a steel rule or a wood rule, but they're measuring tools, they're rulers. Anyway, craft workers most often work with four basic types of measuring tools: flat steel rule, tape measure, wooden folding rule, or laser measuring tool. Accuracy, ease of use, durability, and readability are several factors in choosing a measuring tool. Of course, the chosen tool must also be suited for the length of the measurement. We electricians used to use wooden folding rule because wood supposedly doesn't conduct electricity. I say supposedly because if you get it wet, then it does. So you have to be very careful when using any kind of a measuring tool around any live circuits. Don't ever use a metal tape measure inside of a live panel. Use a wooden, or now they're making fiberglass wood rules, folding rules. Those are nice. The steel rule. The flat steel rule is a simple measuring tool. Flat steel rules are usually 6 or 12 inches long, with metric versions available at 15 centimeters and 30 centimeters. Longer lengths generally for shop use are 1 yard or 1 meter long. Steel rules can be thin and flexible or thicker and rigid. While steel rules are accurate measuring tools, they can also be used as straight edges for layout work. There used to be a question that said the thinner the steel rule, the more accurate, because the measuring side is closer to the work surface. So the thinner the steel rule, the more accurate. Tape measure 2.1.2. The blade of a tape measure or measuring tape is usually marked at 16th inch or 1 millimeter increments, although some tapes offer smaller imperial increments. A tape measure may include both imperial and metric marking for versatility. Tape measures are also available with special markings that apply to residential and light commercial construction wall framing. This is highlighted. The concave, curved as viewed from the top shape of a tape measure is designed to strengthen the blade when it's extended, helping it remain rigid. So you can take this tape and you can extend it out sometimes 6, 7, 8 feet before gravity will fold it. It'll fall, but it helps you make horizontal measurements when you're on a ladder. Sometimes you can extend your tape measure and hook it on something, and then you can get an accurate reading. Module 00102, Introduction to Construction Math, explains how to use and read a tape measure effectively. Remember that the hook on the end of the tape is designed to slide in and out slightly, allowing for accurate inside and outside measurements. That's going to be a highlight there. Wooden folding rule. It says here, highlight. The folding rule can also have special marks at the 16-inch, 19.2-inch, and 24-inch increments to make wall framing easier. So just like they were explaining about tape measures, the folding rule can also have that. This is a very good wooden folding rule. The reason I say that is because this is called inside read. Notice how when you open this tape measure, or this folding rule, that the numbers 1, 2, 3, 4, they're on the inside of the folding rule. There are outside reads where the outside of the rule would have 1, 2, 3, 4, 5. You want to get an inside read. If you're going to get a wood folding rule, get an inside read. Because what happens is you put this in your back pocket and you'll wear away the numbers 1, 2, 3, 4, 5. And those are the numbers you have to really be more accurate. When you're measuring something that's 2.5 inches, you really want these to be accurate. You don't have to be as accurate at 70, 71, 72. So an inside folding rule, that's what you want to get. 2.1.4 laser measuring tools. A laser measuring tool is a battery-powered electronic version of a tape measure. The tool works by simply pointing it at a specific object and then pressing a button. When the button is pressed, a laser beam shoots toward the object and returns to the instrument. The travel time of the beam determines the distance, which is displayed on the screen. Measurements are reported very quickly. Laser measuring tools are designed to report and record in both imperial and metric units. Nowadays, I've seen students with an app on their phone where you take your phone and you get the crosshairs looking at a certain object on the ground, and somehow it triangulates, somehow it can tell how far that is, and you push the button, and then you go to the second position and you click it again, and it'll tell you the distance between there. We did this in a lab class. A student was showing it to me, and I think he was within an eighth of an inch. We measured over 25 feet, and he was within an eighth of an inch. So it all depends on where you're holding that crosshairs, as accurate as you can be. These tools are precision instruments, so ensure they're handled with care and stored appropriately. Following are some advantages of a laser measuring tool has over a traditional tape measure. Long vertical measurements can be taken from the ground. Longer measurements can be taken. Some laser tools can measure up to 600 feet. Special target plate may be required for long distances where more powerful lasers are required. Some laser measuring tools have built-in options to make length-related calculations, such as addition, subtraction, and area, easier to perform. Measurements can be electronically stored on the tool so that measurements can be written down all at once after a task is completed. In addition, many are equipped with Bluetooth communication so that measurements can be sent to a smartphone or a tablet. Some laser measuring tools can have built-in electronic levels or spirit levels. The disadvantages of a laser measuring tool may include accuracy, especially over long distances. This is not to say that they fail to meet their specifications for accuracy, but some craft workers struggle to place their trust in electronic measurements regardless of reported accuracy. In construction, absolute precision is rarely required for very long measurements. It may also be difficult to take accurate measurements in very hot or smoking environments due to beam bouncing from particle to particle in the atmosphere, causing the light to scatter. 2.1.5 Safety and Maintenance. Occasionally apply a few drops of lubricant to the spring joint of a wooden folding rule and steel tape. Wipe moisture from steel tapes to help prevent rust in areas where the coating has become worn or damaged. Do not kink or twist steel tapes. Once a tape is significantly distorted, the damage is permanent. Do not use a steel measuring device near energized electrical components. Do not allow laser measuring tools to get wet or be exposed to excessive heat. If you're on a job site and somebody's using a steel tape measure, have your wits about you. If they have it lying on the ground because they're taking a horizontal measurement on a floor, don't step on their tape measure. If you step on a tape measure, you've just ruined it. You're going to kink that tape. It may even crack when the person lets it coil back into the casing. And it may just keep going. So here's a micrometer. It measures to 1/10,000th of an inch, or 1/10,000th of a centimeter. 2.5 micron is a 10,000th of a centimeter. So 2.54 microns is 1/10,000th of an inch. Levels and layout tools 2.2.0. A level is a tool used to determine how close a surface is to true horizontal plane or vertical plane. If you're talking about vertical, it's plumb. If you're talking about horizontal, it's level. If you're talking about vertical, it's plumb. So if you're talking about a door jamb, chances are you're talking about Plumb. Layout tools include the carpenter square and combination square, which are also introduced here. Some squares are designed specifically for a given craft. For example, although a carpenter square and a pipe fitter square may appear to be identical from a distance, they have different formulas and other information important to their craft. A spirit level. The standard spirit level is the most common leveling instrument in the construction trade. The spirit level got its name because the vials in it are often filled with colored ethanol, a type of alcohol, and alcohol is often referred to as spirits. Alcohol is used because it does not freeze like water and moves more freely inside the vial. Also, over time, if you had water in the vial, it would probably take on mold or some kind of algae growth inside the vial, rendering it useless. So they use this alcohol and it keeps things from growing and it also doesn't freeze. So a lot of times they'll call this your torpedo level. It's 9 inches long. They could also call it a spirit level. It says the center vial is used to check for level and the two end vials are used to check for plumb. Okay, so actually on this, we have a 45-degree angle, we have level, and we have plumb. The reason this is vertical is because if you took this spirit level and you put it vertically on a door, this vial would now be horizontal and you can check for plumb. Plumb is perfectly vertical. For placing level against a surface, be sure there's no debris on the surface that will prevent an accurate measurement. Your level has magnets in it so that it'll stick to metal pipe, but a lot of times it'll also pick up shavings, metal shavings or trash. So make sure you wipe it clean before you use it so that there's no debris throwing off your measurement. There's level. Here he's vertical, so he's checking for plumb. And here's a corner level, post level. It makes sure that the post is level in both orientations. 2.2.2, digital levels. Digital levels provide a digital readout of degrees of slope plus rate of rise to lay out stairs and roofs or determine the fall of a drain line. Some may also use a simulated bubble display for a more traditional feel. Digital levels like the one shown in figure 32 are becoming more common on construction sites due to their versatility. So here's a digital level. Again, you can get an app for your Android phone or your iPhone. You can get a level app. You shouldn't be counting on that to use on the job site. Actually buy yourself a level. 2.2.3 laser levels. Laser levels are used to establish foundation, elevations, and drainage slopes. So here's a laser level. They're very accurate. You need to make sure that the stand that it's sitting on is level, and it has a couple of bullseye levels on it, and you can raise or shorten the 3 legs to get it perfectly level, and then that laser level. Some of them are self-leveling. Some of them you can just put it on a table or put it on a tri-stand, and you push a button, and it has gyros inside of it, and they will self-level, so they'll be perfectly level and plumb. They're very expensive. Don't go near them. If you see one, don't walk up to it. If you knock it off the stand or you knock the stand over, you could have done thousands of dollars of damage to it. So stay away from them. Warning, never look directly into a laser beam. It can permanently damage your eyes and impair your vision. Yeah. For that reason, whenever you're using a laser level, it should be set higher than 6.5 feet or lower than 5 feet. That way you won't be at someone's eye level. You don't want to put them right at 60 inches. That's what my eyes are. They're 60 inches or no, they're 63 inches off the floor. You don't want to put them at a height where someone's going to walk into a room and then get blasted with laser. 2.2.4 Level safety and maintenance. Never look directly into a laser beam or its source. Serious and permanent eye injury can result. Replace a level if a crack or a break appears in any of the vials or if they appear loose and insecure. Keep levels clean and dry. Do not bend or otherwise apply excessive pressure to a level. Do not drop or throw any type of level. I'm not going to read about the bricklayers. I'm sorry. 2.2.5 Squares. Squares are used for making, measuring, and checking to see if a joint is square. Square is a special type of rectangle with 4 equal sides at 90-degree angles. The product of any number of multiplied by itself. For example, 25 is the square of 5, 16 is the square of 4. Also use an adjective in this context to have the shape of a square where 2 components are at a precise 90-degree angle to each other. So I'm not sure why they were telling us that, because I guess you could do a 3, 4, 5 right triangle and measure something to see if it's accurate to an exact 90-degree. The type of square you use depends on type of job that you're performing. Common squares are the carpenter's square, the rafter angle square, also called a speed square, the tri-square, and the combination square. All right, so here's the speed square. You've seen people using these. This is the carpenter's square. This is the tongue, and this is the blade. That's the 2 parts of a carpenter's square, the tongue and the blade. This is a combination square. The carpenter's square, also called a framing square, is L-shaped and is used for squaring up sections of work such as base plates and walls to ensure components are perpendicular to each other. As shown in Figure 35, it is also used to mark square cutting and matching lines, especially when working with wide framing lumber. The carpenter's square has a 24-inch blade and a 16-inch tongue forming a right angle. Metric versions have 600-millimeter blades with 400-millimeter tongues. All right, so this is the carpenter's square, excuse me. Note that the carpenter's square is virtually identical to a pipe fitter's square, except for one feature. On the carpenter's square, there are formulas and other information relevant to carpentry work. Pipe fitter's square has formulas and other helpful information relevant to pipe fitting. A combination square has a ruled blade that slides back and forth in a head. The position of the ruled blade can also be changed as needed. The head's permanently formed into 45-degree and 90-degree angles. Many combination squares also contain a small spirit level and a metal scribe for marking metal. The combination square is one of the most useful squares for layout work because of its versatility. Good combination squares have all metal parts, with the head often made from cast iron and the blade from tempered steel or stainless steel. Here's your combination square. There's your 45-degree. Here's your 90-degree. And you can move it back and forth on this blade. And it also has a spirit level and a scribe. To mark a 45-degree angle using a combination square, again, set the blade so that it's long enough to reach fully across the lumber or metal. Position the back of the head firmly against the edge of the metal to be marked, and use a pencil to follow the blade at a 45-degree angle to make the mark. There you go. Let's see here. Geometry in the square. 2.2.6 Use and maintenance. Do not use a square for something it was not designed for, especially prying or hammering. It's especially important to protect the edges from damage and avoid bending the blades. Keep the squares dry to prevent them from rusting. Use a light coat of silicone spray or lubricant on the blade for protection, and occasionally clean and lubricate the moving parts of a combination square. Do not drop or strike a square hard enough to change the angle between the blade and the head. A tri-square can be more easily damaged by a drop than a carpenter square because of the difference in construction. 2.2.7, a plumb bob. The plumb bob consists of a pointed weight attached to a string. It uses the force of gravity to make the line hang perfectly vertical or plumb. This is a plumb bob. It's held by a string and gravity will make it hang straight. Light poles are tapered. They get smaller at the top than they are at the bottom. You can't use a level to plumb a light pole. You have to use a plumb bob. And the word plumb means vertical. It means straight up and down. So you'll hang that plumb bob with a string and you'll eyeball the center of that light post. That's how they set them on the highways. All the light poles, they use a plumb bob. Years ago, the highest quality plumb bobs were made with large cavity in the center, which was then filled with mercury to increase the weight and concentrate the weight directly above the bob's center point. We've since learned about the health hazards of mercury, and it's no longer used in plumb bobs. So here's a guy using a plumb bob. He's wearing a salad bowl on his head. I don't know why, but yeah, you can, if you know where you want you can lay out light fixtures on the floor. It's a lot easier than taking a ladder or a scaffold and trying to lay them out in the ceiling. Lay them out on the floor, and once you get your marks, you can hang this plumb bob standing either on a ladder or a scaffold. And the mark, you can put this mark on the ceiling, and it shows you the center of where your light fixture is supposed to go. It's a lot easier to lay out on the floor than it is to lay out in the ceiling. So follow these steps to use a plumb bob properly. Make sure the line is attached to the exact top center of the plumb bob. Hang the bob from a horizontal member, such as a door jamb, joist, or beam. To avoid damage, be careful not to drop a plumb bob on its point. When the bob hangs freely and stops swinging, the string is plumb. When using a plumb bob outdoors, be aware that wind may blow it out of true vertical and cause it to swing. Mark the point directly below the tip of the plumb bob. The point is precisely below the point of attachment above. 2.2.8, chalk lines. Chalk lines are used to mark long, straight lines on smooth surfaces. A chalk line is a simple tool consisting of a length of string with a coating of chalk on a reel. So here's a chalk line. Sometimes the chalk boxes come to a point and they can double as a plumb bob, but it says some models can also serve as a lightweight plumb bob. That's a highlight. And here's an example of someone snapping a chalk line. A lot of times you'll have two marks on the floor. They might be 20 feet, 30 feet apart. You need somebody to help you. They'll hold their line on their mark and you hold yours on your mark, and then you snap your side and then they'll snap their side. The chalk inside this box gets on the string, and when you snap it on the floor, it leaves a mark on the floor. So you're using it for a layout tool. Section 2.0.0 section review. It says folding rules with imperial markings come in 6 feet and 8 feet lengths. A carpenter square is also called a framing square. 3.0.0 other common hand tools. Differentiate between various hand saws and their designated applications, identify common clamp designs, explain how different files and utility knives are used with various materials, describe shovels, picks, and other tasks for which each one is best suited. And then it says performance task. You'll have to inspect and demonstrate the safe, proper use of the following hand tools: hand saws, clamps, files, utility knives, shovels. 3.1.0 saws. Hand sawing can be hard work. Using the right saw for the job makes the sawing easier. Saws come in a variety of shapes and sizes, yet all share one important feature: cutting teeth. The shape and size of the teeth are related to the texture of the cut that results and the speed at which the cut is made. So we use hacksaws for our pipe, and they're either 18, 24, or 32 teeth per inch, TPI. 24 gives you a good middle of the road. A lot of people say you're supposed to use 32 teeth per inch to cut metal pipe, EMT, and what have you. You can use 24 or 32. Here's a back saw. It's used for making miter cuts. A keyhole saw is for cutting into drywall and making nice cuts. The drywall saw is a variation of the keyhole saw. It also is used for drywall and for cutting in for boxes and things. A coping saw does delicate, light work, and some people call it a scroll saw because you can make very intricate cuts with it. This is a handsaw for wood, and here's a hacksaw for metal. Like I say, we use hacksaws with 18, 24, or 32. If you're cutting PVC pipe, 18 teeth per inch is a good one to use. That's why I like the 24. It's right in the middle of the road. It'll cut anything. Warning, saw teeth are very sharp. Use gloves and do not handle the saw teeth with bare hands. When cutting with a saw, ensure that your fingers always remain clear of the teeth. So a back saw is used for making miter joints. The standard blade of this saw is 8 to 14 inches long with 11 to 14 teeth per inch. It's used for cutting finished lumber and miter joints. Let's see there. Miter joint. Joints made by fastening parts together with an end cut at a similar angle, usually 90 degrees. Miters, you usually do 45 and 45, and the two of them together will fasten to make a 90-degree miter joint. A keyhole saw, the standard blade of this saw is 12 to 14 inches long with 7 to 8 teeth per inch. It cuts curves quickly in wood, plywood, or wallboard. The coping saw has a narrow, flexible blade attached to a U-shaped frame. Blade can be rotated in the frame to any angle. Blade holders also maintain proper blade tension. Standard blades range from 10 to 20 teeth per inch. The coping saw is used for tight curves and circles in finished carpentry. That should be a highlight. They're used for tight curves. A drywall saw. It's a long, narrow saw used to cut softer building materials quickly. Drywall saws can have a fixed or retractable blade mounted in a wood or plastic handle. Handsaw, that's the standard one we use for wood. Standard blade of this saw is 26 inches long with 8 to 14 teeth per inch for a crosscut saw and 5 to 9 teeth per inch for a rip saw. So a crosscut saw goes against the grain at 90 degrees. A rip saw cuts along the grain. A rip saw is designed to cut with the grain. And of course a hacksaw, the standard blade of the saw is 8 to 16 inches with 14 to 32 teeth per inch. I've only seen them with 18, 24, or 32, but that's what we use for cutting our pipe. 3.1.1 handsaws. The handsaw's blade is made of tempered steel, so it will stay sharp and will not buckle. Handsaws are classified mainly by the characteristic of the teeth. Saw teeth are set or angled alternately in opposite directions to make a kerf. A kerf is the channel created by the saw blade passing through the material, which is equal to the width of the blade teeth. It's slightly wider than the thickness of the saw blade. It keeps the blade from getting stuck in the material you're cutting. Two common types of handsaws are the crosscut saw and the rip saw. Crosscut saw, which has 8 to 14 teeth per inch, is designed to cut across the grain of wood. Rip saw, slower than a rip saw, but leaves a smoother surface. Blade length ranges from 20 to 28 inches. For general use, a 24 or 26 inch blade is a good choice. So follow these steps to use a crosscut saw properly. The kerf should always be taken from the scrap side of the mark. Make sure you don safety glasses and work gloves before beginning. Mark the cut to be made with a square. Also place an X or similar mark on the side of the square line to show which side of the line the cut should be made. You put an X on the piece you're not keeping. You're not keeping it, it's discarded, you put an X on it, and that's the side the blade should be on, because the kerf is going to come off of the bad material, not the piece you want. Make sure the piece to be cut is well supported on a workhorse or similar support. Secure the material with one or more clamps. Plan to support the scrap end as well as the main part of the lumber to keep it from breaking away as the blade nears the end of the cut. Place the saw teeth on the edge of the wood farthest from you, just at the outside edge of the mark. Remember that the edge of the blade should be aligned with a line on the scrap side of the lumber, so that the kerf is removed from the scrap side of the cut. Start the cut with the blade touching the lumber near the handle of the saw, pulling toward your body on the first stroke. Place the saw at about a 45-degree angle to the wood and pull the length of the blade to make a small kerf. Push the blade in the opposite direction to cut and deepen the kerf. Use the thumb of the hand that's not sawing to guide the saw and cut as the cut progresses so that the blade stays perpendicular to the workpiece. Be very careful in doing that. Don't cut your thumb. I would keep my thumb away from that blade if I were you. Do not push too hard or ride the saw into the wood. Let the weight of the saw set the cutting rate. Continue to saw with the blade at a 45-degree angle to the wood. If the saw starts to wander from the line, work the blade back toward it. If the saw blade binds in the kerf, place a wood wedge into the kerf to hold it open. All right, there's your kerf, the part that you took away. Notice how the edge of the kerf is right on the line. This is the piece we want to keep. This is the scrap piece. 3.1.2, safety and maintenance. Brace yourself when sawing so you are not thrown off balance when the scrap separates from the workpiece. Clamp or otherwise secure the workpiece to prevent it from moving while sawing. Clean the saw blades occasionally with fine emery cloth or steel wool and apply a coat of silicone lubricant if it starts to rust. Always lay the saw down gently. If the blade develops a permanent bend or buckle, it cannot be repaired. Good quality saws can be sharpened by crafts workers with the proper equipment and skill. Do not allow the hand saw blade to saw into stone, concrete, or metal, as these materials can easily damage the teeth. 3.2.0, clamps. There are many types and sizes of clamps. Clamps are sized by the maximum opening of the jaw. So this is called a C clamp because it looks like the letter C. This is a locking C clamp. There's a spring clamp. This is one of the oldest clamps we have. It's the hand screw clamp. You can get even distribution of pressure with the hand screw clamp. And here's a bar clamp and a pipe clamp. The C clamp, this multi-purpose clamp, is named for the C-shaped frame. The clamp has a metal shoe at the end of the screw. Using a sliding T-bar handle, the clamp is tightened so it holds the material between the metal jaw of the frame and the shoe. A locking C-clamp, technically this clamp also falls into the category of pliers. The locking feature of these pliers, though, also makes them a versatile clamp. Spring clamp, these simple clamps are spring operated. When the handles are released, the spring holds the clamp tightly shut. Bar clamp is a rectangular piece of steel or aluminum that forms the spine of the bar clamp. It has a fixed jaw at one end and a sliding jaw that moves along the bar. A pipe clamp, this is highlighted. The spine of a pipe clamp is a selected length of pipe. It has one fixed jaw and a movable jaw that slides along the pipe. The movable jaw has a lever mechanism that squeezes the slide to slide it along the spine. A lot of times you can lengthen the pipe on that pipe clamp. You can make it as big as you need it. A hand screw clamp. This clamp has broad wooden jaws that spread the pressure over a wide area. And that's the oldest clamp we have. And web strap. The web strap, although not technically a clamp, uses a belt-like canvas or nylon strap or band to apply even pressure around a bundle of material or to secure a load. There you go. Here's a C-clamp. If you don't want to damage the wood, put a pad or a block, another piece of wood. 3.2.1, safety and maintenance. Store clamps by lightly clamping them to a rack. Discard clamps when bent frames or spines. The spine of a pipe clamp is easily replaced. Clean and lubricate the moving parts occasionally, but do not overdo it. The oil tends to attract and hold dirt and dust. Never use any of the clamps shown for hoisting work. Do not use pipes or other tools to add leverage when tightening a clamp. Doing so allows you to exceed the clamp's capacity and will likely lead to permanent damage. The Romans and their tools. Ancient Egyptians and Greeks used a variety of tools. The Romans, however, are known as the tool makers of the ancient world. The plane, metal cutting saw, draw knife, frame saw, level, square, and claw hammer were all created by the Romans. Yeah, they did good. Files and utility knives. Files and rasps are shaping tools. They're commonly used to remove wood and metal burrs and smooth out rough spots. Warning, it says all types of files and utility knives have sharp points and edges that can cause serious injury. Handle knives and files with extreme caution and the greatest of care. Never use a file or rasp without first installing a handle. 3.3.1, files and rasps. Files and rasps are used to cut, smooth, or shape metal and wood. A variety of files are shown in figure 47. So here's a bunch of files. Files have slanting parallel rows of teeth, while rasps and wood shavers have individual teeth, which are more aggressive. That's going to be a highlight. So the difference between a file and a rasp, I get this question all the time. Files have rows of teeth, where rasps have individual teeth. Rasps and wood shavers, which are also called shredder rasps, are designed for wood and similar soft metals, while files are used for metal. Excuse me, I meant to say it. This is a rasp. You see, wood shavers, cutting face. This is a rasp. This is a file. You can see that it has rows of teeth. Parts of a file are the heel, the belly, and the point. And there are different shapes. You have a half round file. These are very versatile. You have rat tail files, triangle files. These are the ones that you can use for sharpening a saw if you have a triangular file. And here are the rasps. You can see the individual teeth in the rasps. Files textures include the following, listed from the roughest to the smoothest. You have rough, coarse, bastard files, second cut or medium, smooth, and dead smooth. Using a file the wrong way is inefficient and can be frustrating to the user. Follow these steps to use a file properly. Don work gloves and safety glasses. Select a file to ensure the file handle is securely mounted to the file tang. Mount the workpiece to be filed in a vise or with a clamp on a sturdy bench at approximately elbow height. Step back from the vise with your feet approximately 24 inches apart, with the right foot ahead of the left. If you're left-handed, the left foot will be ahead of the right. Do not lean directly over the work. Hold the file handle in one hand and steady the tip of the blade with the other hand. For average work, hold the tip with your thumb on top of the blade and first two fingers under it. For heavy work and larger files, place all of the fingers underneath with the thumb on top. Apply pressure only to the forward stroke as the file cuts in this stroke, placing pressure on the file during the backstroke while the file remains in contact with the workpiece only wears out the file. Raise the file slightly from the work on the back stroke to prepare for the next stroke. Keep the file flat on the work as you continue the sequence of strokes. Utility knives 3.3.2. A utility knife is used to cut a variety of materials, including roofing felt, fiberglass, or asphalt shingles, vinyl or linoleum floor tiles, fiberboard, and drywall. Utility knives can also be used for trimming insulation and opening cartons. They're good because they have replaceable, retractable blades. So people like them because when they get dull, you just throw the blade away and get a new one. This is highlighted. It says, for increased safety, some utility knives automatically retract the blade when the thumb pressure is taken off the blade control. Note that some job sites or employers may require self-retracting knives to maximize safety. As soon as you stop cutting with it, it retracts back into the knife when you take your thumb off. Note the different blade used in the carpenter's knife, or carpet knife. Carpet knife is highly abrasive and hard on blades. Carpet knife blades have two sharpened edges so they can be reversed to extend their usable life. Warning, utility knife blades are extremely sharp, having a razor's edge. Handle these knives with great care and ensure that the blade is safely secured after each use. 3.3.3 Safety and Maintenance. Use the correct file for the material being worked. Always put a handle on a file before using it. Files and rasps are often come without handles when purchased in bulk. After using a file, brush the filings from between the teeth using a file card or wire brush. Brushing parallel to the teeth. A file card has tightly spaced, short, stiff wires on the face that dislodge material from between the file teeth. Store files in a dry place and keep them separated so that they cannot chip or damage each other. Do not allow the work pieces to vibrate in the vise as you file, as it dulls the teeth and produces an irregular surface on the workpiece. Here's a file card. Very short, very stiff metal bristles. These guidelines apply to utility knives. Replace blades when they stop cutting and start tearing the material. Sharp blades are safer than dull ones. Always keep the blades closed and locked when the knife is not in use. Be sure to position yourself properly, keeping your free hand out of the line of the cut. Cut perpendicular to the body, left to right, right to left, or away from the body. Utility knife blades may be somewhat brittle and can snap off easily, leaving a dangerous jagged edge. That's the one reason why I don't like utility knives. They're very brittle. I'd rather use a pocket knife. Shovels and picks, 3.4.0. I have a highlight here. It says a traditional spade is used to shape trenches or holes that need smooth, straight edges. It is flatter than the others and does not have curved sides. However, many variations of the traditional spade are available today. So here's a round-nosed shovel, a square-nosed shovel, and this is a spade. Round shovels and spades are best for digging fresh earth. When using them, place the tip of the shovel where digging or soil removal will begin. Balance a foot on the step at the top of the blade, shift some of your weight to it, and press down to cut into the soil. Square shovels are best for collecting debris from a hard surface or for moving sand and gravel. When using a square shovel, place the leading edge of the shovel blade against the gravel or construction debris and push until the shovel is loaded. They're not really meant for digging holes in the earth. I'm going to highlight that. You place the edge of the shovel blade against the gravel or construction debris and push until the shovel is loaded. All types of shovels can have wooden or fiberglass handles. They generally come in two lengths. Long handles usually 47 to 48 inches long. Short handles usually 27 inches long. Short handles usually have a D-ring on the end to provide a better grip. Generally, the longer handles provide better leverage. but a shovel is not meant to be used as a lever. Roots and other obstructions should first be cleared with other tools like an axe or a hatchet or even a reciprocating saw. A pick consists of a wooden handle that's 36 to 45 inches in length and it has a forged steel head weighing 2 to 3 pounds. Depending on the size and strength of the pick, it can be used to break hardened rocky soil, to level out stones and pavers, to loosen soil, to break up stones and concrete. So here are your two picks. This is a mattox. You use it a lot of times for digging soil. Similar to a pick, a mattock is also used for breaking hard rocky soil and to dig trenches. Mattocks are much better than picks for clearing tree roots. One side of the mattock head has a wide cutting blade as shown in figure 56. The other end may be like a pick or another blade turned 90 degrees from the mattock blade as shown. Mattock handles are rarely longer than 36 inches in length. So this mattock is the one that has two blades, one's turned at 90 degrees. It's for cutting through roots. First step to using a pick or a mattock safely and effectively is to select the length appropriate for your size and the task at hand. Gloves should always be worn as well as steel-toed work boots or shoes along with safety glasses. Place one hand at the end of the handle and place the dominant hand about 2/3 the way up the handle. For tasks using a short-handled pick to strike hard, raise the pick to a near vertical position with the knees bent, plunge the tool into the ground, raise the pick again, and then swing it back toward the ground, using the weight of the tool head and the leverage of the handle to deliver a solid blow. Warning, do not swing a pick or mattock behind or beyond vertical and over your head. Doing so may cause a back injury and significantly reduce the control over the tool. Safety and maintenance. Always check to ensure that the blade is fixed firmly to the handle and no cracks or splits are present. Use the appropriate personal protective equipment when digging, trenching, or clearing debris, including safety glasses and gloves. Wear safety shoes or boots to protect your feet from dropped material and tool blades. Do not leave dirt or debris on blades. Rinse or brush off the shovel after use. Following guidelines for working safely with picks, always check to ensure that the head is fixed firmly to the handle and no cracks or splits are present. Make sure that there are no other workers in the swing path before beginning work. Always use a pick that is the appropriate length and weight for your physical size. Only use maximum force swing when necessary. Hard swings place more strain on your back and shoulders. Do not swing a pick or mattock beyond vertical and over your head. Doing so may cause back injury and significantly reduce control over the tool. Be sure to wear the appropriate eye protection, gloves, and safety shoes or boots. Section 3.0.0 Review. To cut through a metal pipe, the correct saw to use is a hacksaw. Which type of clamp is best suited for a very wide clamping application such as an 8-foot span? That would be the bar clamp. Which of the following file types would leave the smoothest finish? I believe the second cut. These others are kind of rough. Which tool is best for moving gravel? The square shovel. Well, this concludes 00.103 hand tools. If you got anything out of it, please give me a like and consider subscribing to my channel. And as always, I'll see you on the next video. Thank you. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.